In this lesson today, we're going over now all of the characteristics of our graphs of our radical functions. So again, we are including and talking about the square root and cubed root function. We're also now going to add to everything that we've been working on, intervals of increase and decrease, and whether those intervals are also positive or negative values. In this first example, again, notice how with the half graph, let's focus on that starting point. So again, this is our parent function, the square root function. So here we're at 2, 1. This is my x, this is my y, and continuing on here in this direction. So remember, the domain is always the x values and the range is the y values. So notice how the x values are starting where? At 2, right? Because that's the x coordinate. So then the y values are starting at 1 because that's our y coordinate. Then remember, domain being the x, right? Like the x-axis. So we're looking at left and right direction. Remember, left and right, and domain, so that y-axis up and down direction here for the values. So notice how the graph from the starting point is going to the right towards all the positives. So our domain is greater than or equal to. And from here, notice how the graph, we need to go up, which is again towards positive values, so greater than or equal to. Now let's include end behavior. So with the end behavior, remember we're looking at the y value still. So as x is approaching positive infinity, as I'm going to the right, so the right side of the graph, we'll notice on the right side, notice how our graph is continuing on and on up to positive infinity. Then as we're going to the left, towards negative infinity. So now we're reading the left side. So as we're reading it to the left, boom, it stops, remember, at what y value? 1. Now we're going to look at intervals of increase, decrease. So remember, when we're talking about the intervals, we're always looking at the x values now. So remember, end behavior was the y values, f of x is y. And so the interval of increase, decrease, positive, negative, we're going to be looking at the x values. So notice here, and remember, when we're looking at intervals of increase, decrease, always read the graph from left to right. So notice what direction is our graph going. We are going up, we are increasing. So what interval are we going over? Well, again, we are starting here at the x value. Remember, interval is x values at 2. So we're starting at 2. Now notice we're going to use a bracket because we're including 2. Then going on to the right to positive infinity. And notice we don't include infinity. You can include it, so we're going to use parentheses. Then we can look at the interval. So again, our x values from 5 to 8 to see if the values are positive or negative. So again, looking at the x values from 5 to 8. So again, going from 5 to 8. So we're looking at this section of the graph here. Well, where is this interval, or where are these values? Positive. Notice how we're above in the positive, so these values are positive. So again, interval now, guys, with the increase, decrease, we're focusing on the x values. Let's take a look at the next one. Again, here we're going to create that starting point at -1, -3. So -1, -3. Here's my x, here's my y value. And notice we're going in this direction. So again, domain is x values starting at -1. And ranges are y values starting at -3. So now remember, domain is like your x-axis, right? So we're looking at the left and right. So notice from the start, we're going to the left. So now notice the domain, because we're going to the left towards negative infinity, this is less than or equal to values less than or equal to -1. But then from here, notice how we need to go up. So that means our y values are increasing, so greater than or equal to -3. And remember, end behavior, we're looking at f of x values, so that is our y values. So remember, f of x is y. So as x's are going to the right towards positive infinity, on the right side, what happens? Boom. What y value do we stop at? -3. Then as we're going to the left towards negative infinity. So as we're going to the left side, notice what's happening on the left side. We are constantly going up to positive infinity. So now let's do the interval of increase, decrease. So again, read the graph from left to right. Don't look at the arrow. Read the graph from left to right. Notice what direction is the graph going. It's now going down. So this graph is decreasing. And then decreasing over what? X values. Remember, we're looking at X values. So here we're starting all the way over here, right, at negative infinity. So don't include it, put parentheses. And then we're stopping at what X value? -1. And we're including it, so make sure to have the bracket. Now let's look at the X values to see what values, if it's positive or negative. So we're looking at X values from -3 to -1. So we're looking at this section of the graph from -3 to -1. Well, notice how this section here, those y values are below in the negative. So these values are negative, the y values, the values of our graph. So now in example 3 and 4, we're going to include our transformations. Even though I gave you the graph, let's make sure everything matches. Well, notice in this example 3, you have a negative on the outside and 2 here on the outside. So notice what happened to the graph. Well, it reflected and it also moved up 2. Because notice how here we're starting at 0, 2. So notice how here we have our up 2. So we're going 2 up and we reflected over the x-axis. Now let's continue on. Here we go. So this is our x, this is our y. So let's start again with domain and range. So again, domain is your x value, starting again at what value? 0. Good, because that's the x coordinate. That means y values are starting where? At 2, because that is the y coordinate. Then remember domain, the x or x-axis. So we're looking at left and right. From the starting point, the graph is going what direction? To the right, which is towards positive, which is greater than or equal to. Notice from here, what direction is our graph going? Down, towards negative. So negative or less than or equal to. Now let's look at our end behavior. End behavior, remember, is the y value, right? So as x is approaching infinity, what's happening to the right side of the graph? Notice how it's going down, down, down to negative infinity. That's your y values. So now as x's are approaching negative infinity, as we're going to the left, what happens here? Boom, it stops at what y value? At 2. So remember again, looking at those y values. Now let's look at the interval of increase, decrease. Again, read the graph from left to right. What direction is our graph going? Down. So these values are decreasing. Now let's include the interval where they're over what? The whole interval. So x value, right? We're starting here at 0. Remember with the bracket. And then this is tricky because people want to say negative infinity, but we're talking about the x values. So remember, interval is x value. So we're starting at 0 and then going on and on and on. That interval, the x values are on and on into positive infinity. So that's your x values. Now, again, x values from 5 to 8, we're going to see what those values are of the graph, our y value. So from 5 to 8, so we're looking at from here to here, so we're looking at this portion of our graph. Well, notice how this section, our y values are in the negative. So these y values over that interval are negative values. So now we're going to do one more. Example 4, notice how we have our cubed root function. So we have two transformations. Well, I notice here that my starting point is at 2, -1, which if you think about it, that means we went to the right 2 and down 1. So let's see if that matches. Well, notice how this is inside the graph and inside is opposite. So we're going right 2 and then notice -1, so down 1. So that does match our transformation here from the equation. Now let's continue on with domain and range. Remember, this is our cubed root function. So our parent function is a cubed root. So our x values, the domain, are constantly going -infinity to infinity, so all reals. Or you could also put -infinity to infinity. Then our range, again, constantly going up, constantly going down. So again, our range is all reals. Or again, you could have -infinity to infinity, same thing. Now the end behavior. So again, as we're going to the right towards positive infinity, what direction is the right side of our graph going? Notice how we are going on and on up to positive infinity. And as we're going to the left towards negative infinity, our x values, what direction is the left side of our graph going? The y values. Notice how those y values are going down to negative infinity. Now let's look at our interval. So let's see if this graph is increasing or decreasing. Again, always read left to right. So left to right, what's happening? We are constantly increasing, going up. So this is increasing, and this is nice because the interval, there's no starting point, right? We are literally increasing from negative infinity to positive infinity. So from, oh my goodness gracious, from negative infinity to positive infinity. So now let's look to see if these x values, what the values of the function are, if they're positive or negative. So -3 to -1. So from negative, oh my goodness gracious, y'all, sorry about that. From -3 to -1. So we're looking at from here to here, the x value. So we're looking at this portion of the graph to see what the y values are. Notice how we're below in the negative. So these values from -3 to -1 are negative. So go ahead and pause the video. Notice how we're going to also practice graphing in Desmos. So get the quick sketch and try these two on your own. And let's see now how you did. So when graphing the first function, you have the parent function, the square root function. So notice how here you're starting at 0, -4, and then going downward here in that direction here. So starting here at 0, -4, you know what, I'm going to change the color. So from 0, -4, and then continuing on in this direction. So again, 0, -4 was the starting point, my x and my y. So now let's make sure that you got those transformations. Now this one, I noticed that there's actually not one, but two negatives. So you not only have a negative on the outside, which is over the x-axis, but you also have a negative in the inside of the radical, which is over the y. So this is a double reflection. So here we had a reflection, but over the x and y-axis. So that was a double. Then notice how we did move down 4. So notice how we went down 4. You should have also noticed that this looked a little steeper because we do have a vertical stretch that by a value of 3. So this is a vertical stretch. And if you wanted to include, that value was A was equal to 3. Now let's go ahead and get the domain and range. Here we go. Remember domain again, you should have remembered. So x values starting at 0 and y values starting at -4. Again, domain always left and right like the x-axis. Notice the graph here from the starting points going to the left. So that's less than or equal to. And the range, the graph is going down. So again, the y value is going down, so less than or equal to -4. Then N behavior. So let's see how you did with N behavior. So again, the Y values, right? So remember, this is Y values. So as X values are approaching infinity, as we're going to the right, so we're reading the right side of the graph. Boom, you should have noticed that it stops here at what Y value? -4. Then as X's are approaching negative infinity, so now as we're going to the left, you should have noticed that the graph is going down to negative infinity. Then remember, for increase, decrease intervals, always read the graph left to right. So what direction is this graph going from left to right? It's going up. So these values are increasing. So now increasing over what X values, right? Because remember, this is our X's. Well, we're starting all the way over here, right? Because it's starting all the way over in negative infinity. So from negative infinity to what X value is our graph stopping? Right here at 0. So negative infinity to 0. Make sure you have that bracket with 0 to include it. Then let's see how you did with the -8 to -5 X values. So from -8 to -5. So we're looking at this portion of our graph. Remember, it's continuing on. So we're looking at this portion of our graph here. Notice how they are below in the negative Y values. So these values are negative. Now let's check the second U try. Notice how your parent function was a cubed root, so you should have graphed that full graph. So when you graph it, this is how it should have looked. Notice how that middle point now is not going through 0, 0, so it got moved to the right one here, so at 1, 0. So here I also noticed a couple other points, so I'll include them in my quick sketch, like here at -1, 2, and I also noticed this one here at 3, -2. So I'll also include those in my quick sketch. So again, we went to the right one, so 1, 0. Here, let me change the graph, the color again. So at 1, 0, and then I had that -1, 2, and 3, -2. I'm going to go ahead now and include my sketch. Okay. Now let's check. Now I do notice it doesn't look like our normal because it did get reflected. See how we have our negative value? So that is a reflection over the x-axis. Again, here, so a reflection over the x-axis. And just like what we noticed, right, that starting point here now is not at 0, 0, like our middle. It got moved over to the right one. So let's see if that matches, which it does, because remember, anything inside is opposite. So we're going to the right one. So we go to the right one. And then you should have also noticed that this is a little bit flatter as well, because here, or no, I'm sorry, it wasn't flatter. It was kind of like pulled in that upper direction. So now notice here with that value of 4 on the inside, that is our horizontal. Now I like, before identifying if it's a stretch or a shrink, identifying what that value of B is. Again, remember, anything inside the radical is opposite. So even though this is horizontal shifting here, that B value is not equal to 4. B is equal to 1 over 4, which means if B is equal to 1 over 4, this is not a stretch, this is a shrink or a compression. Now let's go ahead and do domain and range. Again, remember, domain is your X values, but again, notice how full graph, so this is all reals. Same thing for the range, continuing on in both directions, so the Y values are all reals. Then the N behavior, right? Remember, we're looking at our Y values. So as X's are approaching to the right towards positive infinity, notice on the right side, our graph is going down to negative infinity. The Y values are going to negative infinity. And as we're going to the left towards negative infinity, notice how our graph is continuing on up and up and up, the Y values towards positive infinity. Then remember, for increase, decrease, we're looking at those X values, so read it left to right. What direction is our graph going? You should have noticed it's constantly going down, so the values of the graph are decreasing, And again, because everything is all reals, we're continuing on from decreasing over negative infinity to infinity. Now let's look at these x values, our interval from -3 to -1. From -3, sorry again, guys, a little touchy here, -3 to -1. So we're looking here at these y values, this portion of the graph over that interval. Notice how we're above the y values in the positive. So the y values over that interval are positive. So now I'm going to go over this double-starred question here, our application. Here you have the speed of the tidal wave s, so in hundreds of miles per hour. And then we have this equation here where t represents the time from its origin in hours. Now, here's something that you need to remember. Whenever we're talking about our equations, if you recall, our equation is always, so whenever we have our equation, it's always equal to f of x, or if you recall, this is our y. So remember, this is, and if another way to think about it is when we have our functions, this is your output. So again, this is your output. This is the y. This is your f of x. So f of x or y is equal to, in this case. Then here that means whatever we have here in the equation is what we're putting in. So this is the input, or this is the x values. Remember, this is always what we would put in. So we're used to seeing this as like y is equal to the square root of x minus 2x plus 6. So again, something to consider and keep that in mind. So as you're looking at part A, it's asking what is the domain for the graph of the tidal wave. So here, domain, that is your x values. Now here's what's tricky about this, because we look at this graph and go, well, my x values, so here I'm starting at 0, 6, right? That's my x, that's my y. And then people go, oh, well, it's continuing on and on. So my domain is x values are greater than or equal to 0, or going from 0 to infinity, right? You have to consider now that this is an application. Could you, so notice how we're starting at the x values going from here to 0 to 4, then notice these, with these x values, what's happening to the graph. Now notice how we're going in the negative values. See here below 0, so this is our x-axis, here's our y. Did you ever have a tidal wave that's in the negative height or negative speed, miles per hour? No. So this means that this portion of the graph we are not going to include because it doesn't make sense. So this tidal wave will never be in that negative value, which means we're only looking at from that 0 to 4. So that means I'm going to mark off A and B. Then now you have to look back and decide, well, what is the x values? What's the domain? We know it's 0 to 4, but what does it relate to? So go back to the equation. What was the x values here according to the equation? T. And what did T represent? Time from its origin in hours. So that's why here the answer is D. Continuing looking at the graph. Now it's asking what interval is this invalid, which we technically talked about in the part A. So like here, they're trying to trick you though, because this says -2 to 0. But guys, if you look at the graph, do we have anything, this graph, or do we have any x values? Because remember, interval is x values. Do we have any portion of the graph from -2 to 0? No. So this isn't even in the graph. So A is not our answer. -2 to infinity. Again, do we have anything over here? No. So it's not even The graph can't even exist here. So we're not even including that. So B is not our answer. 0 to 4. Well, this is the actual part of the graph from 0 to 4. This is what we're looking at here, which means that these aren't invalid, these are valid. So the answer is not C. So notice how D is our invalid because this is talking about the X value starting at 4 to infinity, which notice we're not including because now we're getting into the negative, which means that these values are what are invalid because you can't have a negative speed.